Hello everyone, my name is Isabel. I'm a scientific initiation student at Professor Leonardo Group at University Diadema, and today I will present my work, Mixtures of Ionic Liquids in Coarse-grained Model as Electrolyte for Supercapacitors, developed with the collaboration of Pedro Henrique de Lima Ferreira and supervised by Professor Leonardo Siqueira. Ionic liquids are molten salts at low temperatures widely investigated as electrolyte for energy storage devices such as batteries and supercapacitors. The use of ionic liquids for those applications due to their intrinsic ionic conductivity as well as high chemical and thermal stability and low vapor pressure. In supercapacitors, the ionic liquids play the role of the electrolyte in which charge transport occurs through the migration of ionic species from one electrode to the other. Understanding how they operate then necessitates very large simulation cells with explicit electrodes. These limits the number of systems that can be studied and prevent systematic comparisons. In this case, the coarse-grained model is used to increase the spatial temporal scale of sampling of those computer simulations. In this model, groups in the molecular set form your stud object are surprised and represented by spheres that allow the increase in sample time. The ionic liquids of this work are formed by the mean cation and F2 and BF4 ions, varying the fraction of BF4 to form the mixtures. Figure shows the coarse-grained models for the ions, the parameterization of the coarse-grained model of NTF2 anion, and the optimization of those models were developed by Pedro Henrique. The graphene electrodes also a coarse-grained model, which represent one-third of the graphene mass. So, to compare the results of the Corsican model with the atomic model, we can observe the following figures. From those, it can be said that the large potential drops at the positive electrodes result in smaller capacitance at this electrode than at the negative electrode. And when we look at energy density for our simulated ionic liquids using the Corsican model, the energy density is slightly higher than using the atomic model. Partial model are used to allow the increase of sample scale. Thus, we can take advantage of this model to study the effects that electrode size causes on the electrical properties of the supercapacitor. For this purpose, a system with electrodes approximately 3 times the size of the initial flat electrode was simulated for mean BF4. As shown by the parameters in the table, the size of the electrode did not have a significant effect on charge properties of the system. Compare the parameters of charge per electrode area. The two systems have a value very close, having a ratio close to 1. Therefore, it can be concluded that the electrode size did not have a significant effect on the properties of this specific system. Although Cosquer model have given a space of interesting computer simulations, we don't see many works about the interaction of ionic liquids with porous graphene electrodes in Cosquer model. So we decided to simulate the interface of MinBF4 in porous electrodes, such as figure 6 shows. In figure 7, we can see local charge for the entire positive electrode as function of simulation time. From figure 7, we can see that probably 8 and 16 angstrom pairs when together in the same model have an effect on type of charging and structure of layers between them. For to figure 8, when the three slide sides are associated in the same electrode, the charging mechanisms are different for each one of them. The 8 angstrom pairs use counter-ion adsorption, while 16 and 32 angstrom pairs use ion exchange mechanism. When the model has only 8 angstrom slides, the mechanism is ion exchange. By figure 9, we can also note that the mechanisms are different when the model has only 16 angstrom slides. For negative electrode, ion exchange is observed, but for the positive electrode, counter-ion adsorption is observed. To compare different electrochemical energy storage devices, I'm going to plot like the figure 11 KBUs. Compare the three-pores electrode systems with simulating this work, it can be concluded that, as figure 10 shows, the pore system with three different pores has an intermediate performance relation to the one-size pores. So here are the main conclusions of this work, and I would like to say thank you to the institutions, CNPq, FAPESP, UNIFESP, INEO, LMH, and all my collaborators and all the audience.